Today, we will be doing Exercise C from Chapter 17 of the Giancoli textbook. The first step to figuring out how to do this problem is by reading it. This question is asking, what work is required to bring a charge of little q equals 3 microcoulombs, originally a distance of 1.5 meters, from a charge of big Q equals 20 microcoulombs until it is 0.5 meters away. Now we can start step 2, which is identifying the what. So what do we already know? Well, we know that the charge of little q is equal to 3 microcoulombs. We also know that the charge of big Q is equal to 20 microcoulombs. We know that the initial distance, or RA, is equal to 1.50 meters. And we know that the second distance, or the final distance, RB, is equal to 0.5 meters. And also put in the K constant, which we know is equal to 8.99 times 10 to the 9 SI units. This brings us to the third step, which is identifying the correct equation to use. So as we can see, we're trying to find what the work is. So we'll use the equation WEXT equals little q times VB minus VA. However, we don't know what the values of VB or VA are, so that's what we need to find, which will bring us to another equation. For this equation, we can use VB is equal to the K constant times big Q over RB. And VA is equal to the K constant times Q over RA. We can plug the values into the equation and then put them in our calculators to find the value. After plugging them into my calculator, I get that the value of VB is equal to 359,600. And the value for V of A is equal to 119,866.67. Now I can go back to the original equation that we wrote, which is equal to WEXT equals little q times VB minus VA. Now, since we know the values of VB and VA, we can plug these into the equation above. After doing a little bit of math, we can get that the work is equal to 0.72 joules. And that, my friends, is our final answer.